Okay, the next step is to calculate the participants' support for the law or court ruling described in this scenario and items related to that. To show you what one example item looks like, I'm going to tabulate this currently legal one. So these were 7-point rating scales. Uh, Participants who saw but skipped the item got coded as -99. There's one participant who did that for this currently legal item. And there's 12 rows in the data set that have missing values in this version of the variable, which means that those participants never even got to that point. One of them, for example, is going to be this um, ineligible participant who wasn't shown that question on purpose. This question is fairly straightforward. It's sort of an attention check asking them if it is currently legal to discriminate on the basis of mental illness in hiring, which most of them don't have prior knowledge of, so they should just trust the scenario, or at least this will indicate the extent to which they did just trust the scenario. So those -99s are helpful for me initially in distinguishing between people who purposely skipped the item and people who never saw it in the first place. But most of the time I would just like to convert them to regular missing values. And so I have a long uh, set of lines of code here that does that using the recode command from the car package. There are ways to do this that are much easier. You could do it with a single line of code using subsetting and replacement. But um, this, I think, is very easy to understand, so I've done it this way here. So each of these lines of code takes a variable currently legal in camel case from the data frame, the raw data frame, and recodes it so that -99s become missing values, and saves the result in the global environment with a similar variable name that's not in camel case. So remember, currently legal, this version of currently legal, is in data.raw. This variable, because I haven't specified any kind of data frame um, like that, right? To put it in, it's just going to be a vector in the global environment. So having run that, I can tabulate that and see that it worked as expected. Now there's 13 missing values instead of 12, and this -99 is absent. I can run all of these, and they all work as expected. By the way, all of those are now in the global environment, right? So should be illegal, for example, most want illegal. They're all in the global environment. These are all questions that we asked the participants about the scenario. So things like it should be legal or illegal for companies to discriminate on the basis of history of depression. The company should be punished, or I would support the company. I would vote to ban this kind of discrimination, or I would vote to allow this kind of discrimination. I think that most people want it to be legal or illegal to discriminate on the basis of mental illness. It's moral. Most people believe it's moral. It's wrong. Most people believe it's wrong. Those kinds of questions. Right, so here's the example that I just showed you. I'm probably going to combine some of these items up here into scale scores. And normally I would do the analysis to figure out how to combine them if I didn't have some a priori way of combining them in a separate file, because that's important results that I would want to report. In this case, we have some a priori ways that we want to combine them, but just to illustrate how you might do a PCA if you wanted to, I'm going to use the principal function from the psych package here. And I'm going to use these variables that are in the global environment. They're in the global environment, so I have to C-bind them in order to create a matrix out of them so that principal will get the kind of object it expects as its first argument. So I'm going to take all of these items that I've just worked with up here, replacing the -9s with 99s with missing values. I'm going to C-bind them together. That's what this does. And I'm going to plug that in as the first argument to principal. And then there are two more arguments to principal. N factors equals 4 and rotate equals varimax. N factors equals 4, I would, change depending on what I learn about the, for example, the eigenvalues or other information about the results of the PCA. But in this case, I've already looked at the results, so I decided 4 was an okay number. And I've stored the result in something I've called PCA1, just an arbitrary name for the output of this principal function. These are the eigenvalues. There were 20 items, so there's 20 of these. And this is a plot of those values, scree plot. Sometimes people look for a drop-off or an elbow. It's pretty hard to judge this particular scree plot, but I could justify including maybe 4 or 5 components. But with 4, I get some sensible information. So this first component seems to be primarily about people's sort of personal opinion about um, the policy in question, the kind of discrimination that was described in the scenario. And then the second component seems to be about judgments of other people's opinions, the legality and the morality. Um, and then the third component seems to be the manipulation check, the memory for what the scenario actually said. And then this item, oh yeah, this item I didn't explain to you, but it's just different from all the others conceptually, and so I'm not surprised that it came out on its own component here, and that's probably why I included 4 instead of 3, because I didn't want um, this one to muddy up any of the others. I'm not going to use these components in any formal way. It's just a way to help reassure myself that um, that the items hang together about as I expected them to. Questions?
I had a quick question about the code. So when you have the rotate equals varimax,
Yeah.
what does that indicate?
This set of loadings is a rotated set of loadings, and it uses the varimax rotation. I'm checking on something because I don't want to give you wrong information.
Sure.
Yep. Okay, that's the issue. The principal function has a default value of rotate equal to varimax. So that
Oh,
argument
okay.
didn't do anything. Um, but it's pretty standard in a lot of software packages to show you the unrotated solution to the PCA first, which often just tends to be a little bit less conceptually useful.
Okay.
Because the components are not as exaggeratedly distinct um,
Okay.
as they are when you apply the varimax rotation, um, which sort of makes them as distinct as they possibly can be. I'm not trying to obtain a set of factor loadings that I'm going to actually use computationally.
hmm
Instead, I would like to just learn about if I was going to choose subsets of these items to combine together, what are reasonable subsets? Like, what are, if I was going to try and distinguish the items as best as I can from one another, how could I do that? I have hypotheses about whether the personal opinion about, say, the company should be punished would be associated with the belief that most other people believe that this behavior is wrong. Um,
hmm
the correlations among these items suggest that those are at least empirically distinguishable. But this is all maybe a little bit like, uh, so if you are actually constructing a new scale in an exploratory fashion, then you could take the whole class on like scale construction and exploratory factor analysis, and then carrying out another study and doing confirmatory factor analysis and all of that stuff, which is sort of beyond the scope of this workshop. But in
hmm
this case, I just wanted to show an example of how you could do a quick PCA if you wanted. Um, Although in this case, the groupings of items I already kind of had in mind ahead of time, like the personal opinion and the judgment about what most people believe, I was already planning to treat those as distinct concepts, even without having done this PCA.
Okay, that makes sense. Thank you.
Sure. Okay, so here, the next thing I'm going to do is just look at some correlations among these items. So again, I'm using cbind to create a matrix of items. Oh, really a data frame of these vectors here. and I'm going to plug them into the core function, which calculates a correlation matrix. So just to illustrate, this cbind function, um, the cbind function gives me a data frame that has just those columns in it, and it has all of them, but I printed this with just the head of it so that you could just see the first 6 rows of that data frame. Plugging that into the core function, like this, would give me information about the correlations between all of those items. But this matrix is full of NAs because all of those items have at least some missing values, for example, because there was one participant who was ineligible and then didn't answer any of the questions. So I'm going to add an argument to the core function that tells it what information to use to calculate each correlation. And I'm going to start by just doing use equals pair, which stands for pairwise complete observations. And then so this correlation matrix will be based on whichever cases have valid responses for each pair of observations in the matrix. And I'm going to assign the result of that core function to this variable named cormat1. And I'm putting the whole thing in parentheses because I also want to see the correlation matrix printed to the console. So this is a handy trick if you're doing stuff in R and you have a line of code that assigns a value to a variable, like this one does, using the single equal sign as the assignment operator here. If you put the whole line of code in parentheses, then it carries out the variable assignment and also prints the value of the variable to the console. Here I have that. I have this big correlation matrix that's wrapping across lines, but it's still a matrix. Between all of the variables that I included here. And these are all of the personal opinions about the discrimination on the basis of illness history. So whether the participant thinks it should be legal or illegal, the company should or should not be punished. Um, uh, how the judge should have ruled in this case, whether they would vote to change the law, whether it's moral for the company to have discriminated, and so forth. And a quick scan suggests that these are all pretty strong correlations, but I might just be interested, for example, in the weakest correlation. So here I'm taking that correlation matrix, calculating the absolute values, so stripping all the negative signs, and then asking for the minimum of that, and that's 0.45. 0.45 is a pretty strong correlation, and it's the weakest one among this set of items. So this is just me providing myself with a little further reassurance that if I include all of these items, if I average all of these items together and treat them as a single set of indicators of a particular psychological experience, namely like thinking it's okay or not okay for this kind of discrimination to take place, that's not an unreasonable thing to do. So I'm going to go ahead and do it. The PCA was already one way of like reassuring myself about that, but looking at these correlations is another way. I'm also going to look at a similar kind of correlation matrix for these other items about what most people believe. So these ones are all what the participant believes. This is what the participant thinks most other people believe. There's fewer of these items, so I can just scan all of the correlations right here. There's only 6 of them. But I can also run this same minimum absolute value line in order to see that the minimum is 0.39, the minimum absolute value, which is this one between most people want it to be illegal and most people believe that it is immoral, which makes sense because those are the most differently phrased of these items. But I'm going to treat these 4 as indicators of the same basic concept too, which is based on, is consistent with what I was already planning to do ahead of time. I just want to reassure myself that that's not an unreasonable thing to do. And finally, I'm going to look at the correlation between the currently legal and currently illegal items, which is negative 0.71. So that's reassuring too, even though I don't care as much about those items because they're just kind of a manipulation check. And the last thing I'm going to do before I pause until next time is combine these items into the scale scores that I'm planning to use. So this one I'm calling I support discrim for I support discrimination, which means not me, the researcher, but the participant. This is just the shorthand I've used for the participant has reported that they support the form of discrimination described in the scenario. I didn't call it discrimination, of course, except for the fact that the Amy sued for discrimination, but that has sort of a negative connotation. But this is the participant supports the company's behavior. I've C-binded all those same items, and I'm just calculating row means. Some of the items I've reverse scored. I just did it directly in the C-bind function. I didn't have to reverse score them ahead of time. And now I have this single I support discrimination um, variable stored in the global environment. So I can like look at the beginning of it. For example, the first case is missing. I think that was a person who was ineligible or a preview or something. And then I have these specific scores. And I can do the same for most people support discrimination and the belief that discrimination is currently legal, which is basically a manipulation check. Yeah.
Sarah, I have a quick question. For the principal components analysis, you did not reverse score before that. So I assume that means that you would still get the same loadings with and without reverse scoring?
So here's the table of loadings. By default, it's printing this table so that ones that are close to 0 are just not displayed, but I could make it print all of them if I wanted to. And you can see that some of them are negative. So should be legal and should be illegal here have the opposite signs. If I had reverse scored should be legal, the loading would have been 0.809 instead of negative 0.809. But I like to leave them as they are originally when I do a PCA because I want to know which ones are reversed.
Thank you.
No problem. Anything else? Okay, I'll pick up from here next time. We'll probably, so I know it seems like we haven't gotten that far, but a lot of this is repetition later on. So next time I'm planning to finish walking through this example data set, and then the time after that we'll talk about some plotting. And yeah,